Oh, I gotta get these chickens out of here. Oh, boy. That took care of them. Okay, differential equations as models, Unit 1, Lesson 4. The most commonly seen one involves exponential growth or exponential decay, and you've probably seen this type of problem before, maybe even in a pre-calculus type class. So the symbol tilde stands for is proportional to instead of is equal to, and writing out these models, and you might look at them carefully and see they're really all the same exact model. They really aren't different. So here's one of them. Population growth. The change in a population is proportional to the size of the population. So P prime is proportional to P. And if we fill in our constant of proportions, K, that means P prime equals K times P. So the change in population is proportional to the population itself. That's why larger countries like India have large population growths every year. All right. Radioactive decay. The change in the amount of a radioactive substance is proportional to the amount of the substance presence. A prime is proportional to A. Or written as a differential equation, dA dt equals K times A, where K is a proportion constant. By the way, K differs with different elements that are radioactive. Some deteriorate faster than others. And K will be a negative number in the case of population, or radioactive decay. By the way, K would be a negative number in this one if the population we're looking at was shrinking exponentially. So, also, it shows up in finance, continuously compounded interest. Just if you need a refresher, what that means is, instead of compounding interest, let's say quarterly or monthly or even daily, it's compounded continuously, where the compounding period shrinks to zero and the number of compoundings per year grows infinitely large. And then the formula for compound interest actually winds up being the change in the amount of money is the growth rate times the amount of money you started with. And K is the interest rate in this case. Newton's law of cooling is almost the same. For this one, it says the change in the difference between the temperature of the object and the surrounding medium is proportional to the difference in temperature of the object and the surrounding medium. So this is a difference in temperature is proportional to a difference in temperature. Okay, I should say the change in the difference of temperature is proportional to the actual difference in temperature. So there's the change, constant of proportions, times the difference between the object and the media that surrounds it. Also applies in case it's warming up. It's just then K would be a positive number in that case. So K is either the growth or decay rate in all these, and if you really look at it, you know, change the parameter or change the variable I'm using, but they are all the same. And we will solve this separable differential equation in the next lesson, and it's actually pretty easy. I think we solved it separable in the last lesson as well, but that's up and coming. I hope that worked for you. Oh, no, we got ducks. Oh,